happy Exponential Review Day. Hopefully you have this warm-up sheet sitting in front of you right now. This is a review of exponential functions, some of the stuff that I think you're going to have trouble with if you have trouble with anything on the test tomorrow. So I wanted to go through this sheet with you first, then talk about some stuff on the review sheet, and then if there's time left at the end, you can start working on this review. Okay, so number one is an exponential equation. I've got 1 to the 1/27th to the x equals 9 to the 3x squared minus 9. What do you do first? You got to find common bases. Okay, so we've got to look between 1/27th and 9. We need to be able to rewrite both of these so that they have the same base. Right now we've got one base of 1/27th and one of 9. So what is the common base? Right, it's 3. So common base 3. And that means I can rewrite both of these sides as 3 to 1 power. Remember, I'm not changing the values, I'm just rewriting. So what I told you to do was when you see a fraction, what does that mean? Negative exponents. So 27 and 9. 27 is 3 to what power? 3 to the third. Still raised to the x out there. Over here I have 9, which is really 3 squared. Still raised to the 3x squared minus 9. But since 1/27th is a fraction, it's not just 3 cubed, it's 3 to the negative 3, right? Okay, so next up, we have to distribute. Don't forget to do that step of distributing those exponents, because otherwise rewriting it had no purpose. So this would be 3 to the negative 3x equals 3 to the 6x squared minus 18. And once you have common bases, what can you do? You can set the exponents equal. So negative 3x equals 6x squared minus 18. Come over here. Since it's an x squared equation, we got to bring everything over to the right side in this case. So 0 equals 6x squared plus 3x minus 18. Now how do I solve an equation like that? I factor. And what do I need to do first? GCF. So there's a GCF here of 3. So if I take a 3 out, that leaves me with 2x squared plus x minus 6. And then how do I factor that? Reverse box. So let me draw up here. We have 2x squared. We have negative 6. So this is definitely going to be 2x and x. And we got to multiply to 6. There's no GCF anymore. So probably 3 and 2. Let's put a 3 here and a 2 here. This is a 4x. This is a 3x. If I need a positive x in the middle, I need a plus 4x and a minus 3x. So we have 0 equals 3 times 2x minus 3 times x plus 2. Draw your walls. 3 equals 0 is nonsense. This is going to give me in the end x equals 3 halves, and this is going to give me x equals negative 2. Now remember, there's never any rejecting with exponential equations. The domain of exponentials is all real numbers, so there's no potential domain issues, so you don't have to worry about checking or rejecting. You can always do y1, y2 calc intersect, but you don't have to. Alright, so that's number one. Any questions so far? Good. Moving on to number two. Okay, number two, I'm going to need my calculator for. Find an equation for the exponential function of the form y equals a to the b equals b to the x that passes through the points negative 3, 108, and 2, 4/9. So remember, the easiest way to do this is by using a regression equation. So I want to see a table. L1, L2. We're going to put in the point negative 3, 108, and 2, 4/9. So here's my calculator. I go to Stats, Edit, clear out any lists that are in there. -3 and 2. And then over here we have 108 and 4/9. Okay, then where do I go? I go to Stat, Calc, and all the way down to choice 0 for exponential regression. New calculators obviously will have that screen. This old calculator, I just got to write L1, L2 and hit enter, and you should see that. Okay, so I would like to see Stat, Calc, EXPReg, and then we write our equation. It's going to be 4 times, now this is really what? 1/3 to the x. So we've got 4 times 1/3 to the x. And why would I lose a point there? Because I need y equals. And look at their form. They want it as y equals. So y equals 4 times 1/3 to the x. Soupies. Okay. Now what gets a little not soupies is these next types of questions. These percent manipulation questions. This says the cost of cable has been increasing by a rate of 7.5% each year. What is the monthly growth rate of the cost of cable rounded to the nearest 1/10 of a percent? Now for the test tomorrow, you're going to need to know 3 equations. We've got A equals P times 1 plus or minus R to the T. We've got A equals P times 1 plus R over N to the NT. And we've got So remember the key words. Which of these 3 would you use if you saw the word continuously? Per sure, per. Continuously always means E, so per. How about the word compounded anything other than continuously? That's that middle one. So this is compounded not continuously. And then this one is just for if you see anything about an annual rate. It could be growth or decay. Okay, so this one is increasing by a rate of 7.5% each year. That's an annual rate. So right away, we've got this equation, the top one. A equals P times 1 plus, because it's been increasing, 0.075 raised to the T. Now our goal is, what is the monthly growth rate? So the rate is all in this spot right here. And remember, think about your units. So right now, what would T be in? Well, since 0.075 is the yearly rate, T is in years. And again, that's because that's got to agree, so that's a yearly rate there. So if I want a monthly rate, what would I have to plug in for T? So monthly, in terms of years, 1 month is 1/12 of a year. So if I want to know what this monthly rate is, I have 1.075 raised to the 1/12 equals 1 plus R. So if I plug in 1/12, I get a monthly rate, and I got to get rid of that 1 so that I can see what it actually is. All right, so let me plug this in. We're going to have 1.075 raised to the 1/12 in the exponent. It gives me that number, 1.0060, blah, blah, blah. And when I subtract 1, I'm just going to have 0.0060 equals R. We can move that decimal place 2 to the right. That's 0.0060, so that means it's about a 0.6%. So it says 0.6% monthly increase. Okay, so then part B kind of goes along with that. If the cost of cable can be described by this function, C of t equals 125 times 1.075 to the t, where t is the number of years from now, find a formula for the cost of cable t years from now in terms of a monthly growth rate. So we just found out again that the monthly rate was 0.6%. So that means R is going to be 0.006. That number out front represents what? Right, just the initial amount, so that's not going to change. We're going to need to put in our new R value, 1 plus 0.006. And if I just put to the t, I have a problem because t, they want t to be in years. So t is in years. So 0.006 is in months. So if I put in 1 year, how many of those rates are going to get applied? Well, since it's only monthly and t is in years, we're going to have 12. So if t was 1, I would really want 12 of these applied. So I got to put a 12 here so that that accounts for each month in that year. So that's my answer. So when I have to make an equation, I have to put in the R value that I need and make sure the exponent agrees with how many of those rates are being applied. Okay. Over on the back, last part for this sheet. Here we go. What is the percent rate of change to the nearest percent for each of the following exponential functions? So we want the percent rate of change. We're looking for R. This is where I have to figure out, okay, my equation, A equals P times 1 plus R to the T. Remember, I'm looking for what's the base that's being raised to the T power. That's an R. What is the base that's being raised to the T power? So I've got to isolate that T. So I have n sub 0 times something all raised to the T. In this case, the something would be 1/5 to the 1 over 4.327. So it's this piece right here, 1/5 to the 1 over 4.327. That's equaling that 1 plus R piece that I need. So I plug that into my calculator. Careful of parentheses if you have an older calculator, or make sure you're using alpha y equals if you have a newer one. 1 divided 4.327 gives me that number, 0.6893, blah, blah, blah. Subtract 1. Definitely got some decay going on here. So negative 0.3106. So that decay rate is about a 31% decay rate. Okay, second one over here, pretty similar. I want to first isolate that variable of x, y equals something being raised to the x. Now everything here is being raised to that exponent, so it's just going to be 3 to the negative 2 that's being raised to the x. So that's equivalent. So that means this thing in the middle, 3 to the negative 2 equals 1 plus r. I could plug that into my calculator if I want, but I know that's just 1 over 3 squared, so that's going to be 1/9 equals 1 plus r. Subtract the 1. And we'd rather see this as a decimal anyway. So 1/9 minus 1, negative 0.888, repeat. So that means we've got R is about an 88% decay rate. JK, that's an 89% decay rate. Thanks for noticing that. Okay, so those are some of the trickiest questions that could be on the test tomorrow, so hopefully that'll give you some frame of reference. If you take out this review sheet that I handed out yesterday, let's talk through that real quick. If you didn't get it yesterday, There should be some extra copies around, so raise your hand and ask for one, and one will be delivered to you, hopefully. If not, you can always print it off my website. All right, so I kind of looked through this ahead of time and picked out some specific things I'd like to go over with you guys. We started the unit with exponential function families right before spring break. Remember, every exponential function's parent function is y equals some base raised to the x. And they start with a y-intercept of 0, 1, horizontal asymptote of y equals 0. That accuracy point is what you get when you plug 1 into the parent function. So it's always going to be 1 comma b. We talked about transformations. The domain is negative infinity to infinity always, but the range depends on what the graph looks like and the horizontal asymptote. So this whole section, we did a bunch of them back when we did them originally, is this section right here. And I figured number 2 would be a good one to look at. So if you haven't already done that, why don't you start a blank sheet of paper or do number 2 somewhere. You won't have room to squeeze it all in here, so you'll definitely need a blank sheet of paper. So here's that question that I wanted to go over. And it doesn't matter if it's out of order from yours, but start this on a blank sheet of paper somewhere. You'll really get the paper out if you haven't done it already. I want to make sure we go through this together, so get the paper out. Okay, so first step is to find the parent function. So what would you say the parent function is here? 1/2 to the x, okay. I'm hearing a lot of 1/2 to the x's. Why would that lose you a point on the test tomorrow? Because that's not a parent function, that's a parent expression. You need to write y equals or f of x equals. Okay, then what can I fill in this chart? Well, I know the y-intercept of the parent function is always what? 0, 1. I know the asymptote always starts at y equals 0. What would my accuracy point be? Okay, so that's what I was talking about. We plug in any other value. X equals 1 is the easiest. So if I plug 1 in, what do I get? 1/2 to the first, so 1/2. Now in order to do this transform function thing, I have to list out the transformations. And the order matters here. If you get the order wrong, it could throw off the whole graph. What order do you have to go in? PEMDAS, right? So first, we have parentheses. Is there anything in these parentheses that is not in the parent function? No. So P is done. Actually, let's circle what is in this function that's not in the parent function. What does this function have that the parent doesn't have? It has a -2 and it has a +4. So next up is exponents. There's nothing in the exponent that wasn't in the parent, so that's done. Multiply, divide. There is something being multiplied. There's this -2. And that's actually 2 transformations. What's one thing that's happening? Right, a reflection in which axis? The x-axis. And what does that affect? Well, is it directly attached to the x? No, so it affects the y's. What's it doing to the y's? Negating them. So we negate the y's. That 2 is also being multiplied. So what's that? You can call it vertical dilation or vertical stretch. Either way is fine. Vertical stretch by 2. What does that affect? Also not directly attached to the x, so that affects the y's too. What do we do to the y's? They're being multiplied by 2, right? So multiply, divide is done. Add, subtract is last. +4 is being added on to the end. So what does that affect? That's a translate up 4. And that also affects the y's, y +4. So these are the steps that I have to apply. You see nothing's happening to the x's, so that 0 is going to stay 0. But we're going to have to negate the 1, so -1 times 2 is -2 plus 4. -2 plus 4 is 2. Asymptote, negating 0, still 0, times 2, still 0. Up 4 would be y equals 4. And then last one there, accuracy point. We said nothing happens to the x for this one. Negating y makes it -1/2. -1/2 times 2 is -1. And +4. -1 plus 4 is 3. So that gives me all the values that I can plot now. So we have 0, 2, y equals 4, asymptote, make sure you draw that in, and 1, 3. And when I connect those points, I know I can't plow through the asymptote, so it's got to level off that way, go down forever this way. And the last thing asked for domain and range. What's the domain here? That's a sup ease point tomorrow. It's always negative infinity to infinity for exponentials. The range, remember, you always have to go low to high. What's the lowest value here? Negative infinity, and the highest, 4, but it doesn't reach it. That's why you put a parenthesis. Okay, so make sure you know how to do those big graphing transformations. You can expect one of those tomorrow. Okay, next up we had exponential equations. That's just the L1, L2 thing. We did one of those. Solving exponential equations, getting like bases. Don't forget to distribute the exponents. Fractions just mean there's a negative exponent. So I don't really want to go exactly through this one, but when I look at something like 6, I know there's a negative exponent involved. What would be the common base? Well, 2 and 4 are both right, actually. You could use 4 to the negative second equals 4 cubed, or you could do 2 to the negative fourth equals 2 to the sixth. Either way, but I think you got how to do those. Applications, we talked about knowing these 3 equations. Annual growth or decay is the first one. If you're compounded not continuously, you're using that second one. Continuously means PERT. Percent manipulations we did recently also on that practice sheet. Those are the kind of obnoxious questions, but we've done a lot of practice with those. And then there's that half-life formula that we talked about recently. Okay, so let's see, is there anything else I wanted to go over here? Those were fine, I think. Let's look at number 12. Take a look at number 12 real quick. To make class more difficult, Mr. Laley decides he needs to increase the amount of homework he gives by 5% each night. Sounds like something I would do. If he keeps this up, by what percent growth rate will he be increasing homework each week? Round your answer to the nearest tenth of a percent. Okay, so let's see what we've got here. That's my initial R value, but that's a daily rate. So I would have A equals P times 1 plus 0.05 raised to the T. But keep in mind, that T is in days here. So if I want a weekly rate, if I want to know how much it increases in 1 week, what would have to go in for T? Not 1/7, because it's not 1/7 of a day. 1 week is 7 days. So I'd have to plug in T equals 7. So I would have A equals P times 1.05 to the 7th, and we would take this piece and set it equal to 1 plus R. So I would do 1.05 raised to the 7th, so that's how much I'd increase per week. So I'd have 1.407. 4 equals 1 plus R. Subtract the 1, we'll have 0.407 equals R. So that means my weekly rate is 40.7 to the nearest tenth of a percent. Oops, I better check, make sure it's nearest tenth. Yep, it's 7.1. So if you want to put a 1 there, you can. That's a 40.7% rate. Okay, so those questions, that's how you would answer one like that. This is one of those ones where we have to change the equation. We did one like that on the warm-up sheet, so I'm not going to redo that. Number 15, you see population is decreasing continuously, so what's that going to mean for you? That for sure we're using PERT for this one. We've got a regression equation. Watch out for using x equals 1 to represent 1986, so you're not just going to put these into L1. You're going to put 1, 2, 3, etc. into L1. All right, I think that's about it. So you got to finish up that review sheet if you haven't already for the test tomorrow. I'll clock that at the beginning. And lastly, let's see how much I'm doing on time here. Okay, let's look at what you're not allowed to forget. So pull out this sheet, your obnoxious orange sheet. And we need to go on the back over to Unit 11, Exponential Functions and Equations. I guess what I really want to write down is the formulas, because you have to know those for the test, and those aren't on the formula sheet. So we've got A equals P times 1 plus or minus R to the T. That's annual rates, growth or decay. We've got A equals P times 1 plus R over N to the NT. That's for compounding. Not continuously. Then we've got A equals P e to the RT. And that's when you see the word continuously. So that's really the big stuff to remember from this unit. You have to have those formulas memorized on the Regents and the test tomorrow. Other than that, a lot of the stuff that we did isn't necessarily super important for the Regents. That mindful percent manipulation, so I'm just going to maybe write it in here so that you remember to look over that. That's pretty much guaranteed to be on every Regents ever. So I'm just going to write it down so that you know to go back and review that when it gets to be Regents time. Make sure you know how to do that. Otherwise, I think we are pretty good. All right, so if there's any time left in class, you can use that to work on the review sheet. Otherwise, finish that up for homework. I'll be in school early tomorrow before the test, so if you have any super big questions, try to come see me. But otherwise, good luck.